Hello and welcome to the exercise section of part 1 of our video series on pre-calculus. In this video, we are going to go through tons of examples on function, and in the process, we are going to introduce the difference quotient formula. So in part 1, we talked about what a function is and how to identify if a particular relation is a function or not, by either using a table or by using the function itself. So now you should grab yourself a cup of cold juice, take a pen and a paper, relax as I decode some of these difficult concepts for you. Let's quickly begin with example number 1 without any further ado. Example number 1 says, which table, table 1, 2, or 3, represents a function, if any? So which one of these tables represents a function? Table 1, we have the input value 258 and the output value 136. But recall, we told you in part 1 of
this video series,
we said that a particular relation is a function if the x value does not repeat, or each input value should have only one output value. So let's look at table 1. 2 is an input value and its output value is 1. 5 has an output value of 3. 8 also has an output value of 6. So because 2 has only one output value, 5 has only one output value, and 8 also has only one output value, therefore table 1 is a function. We say is a function. Let's move on to table 2. Table 2 we have as input values -3, 5, and 5. As output value 0, 2, and 7. So is this a function or not? Let's find out. -3 has an output value of 0. 5 has an output value of 2. And 5 also has an output value of 7. So because 5 does not have only one output value, it has two different output values, therefore we say this table is not a function. Now, so this is a function and this is not a function. Let's look at the third table. We have input values of 104, output value of 515. So 1 maps to 5, 0 maps to 1, and 4 maps to 5. Now here we have each input value having only one output value. For the fact that we do not have this input value repeating, we say that this is a function. Why is this a function? Because each input value has only one output value. It doesn't matter if the output value repeats, but the input value should not repeat. So this is a function. Now let's move on to example number 2. We are told to evaluate f of x equals x squared plus 3x minus 4 at a x equals to 2. So let's explain what we mean when we say evaluate this function at this particular point. X is called the independent variable here, and f of x, which is the same as y, is called the dependent variable. So what we'll do is we'll rewrite the function solution. We rewrite f of x equals x squared plus 3x minus 4. And then we want to know the output value. What will be the output value, which is the value of y, if we take the input value as 2. If we put 2 into this function, what do we get? So f of 2 at x equals 2 is equals to 2 squared plus, this is 3x, so we are multiplying 3 times 2. 3 times 2 minus 4. So f of 2, which is the y value when x equals 2. 2 squared is 4 plus 3 times 2, that's 6, minus 4. f of 2 equals to 4 plus 6, that's 10. 10 minus 4. So f of 2 will be 10 minus 4, that's just 6. And also realize that we will just cancel 4 and this 4. So 4 minus 4 is 0. We're just left with 6. So for B, we are told to evaluate f of a plus h. Let's quickly move on to evaluate f of a plus h when x equals a plus h. So f of x is equals to x squared plus 3x minus 4. We replace x with a plus h. So f of a plus h is equals to, once we see an x here, we replace that with a plus h. So it's a plus h all squared plus 3 times a plus h minus 4. And then we can move on to simplify. This is binomial. We're going to expand this binomial, a plus h all squared, where it has a plus h times a plus h. And then we'll move on to say 3 times a, that's 3a, 3 times h, that's 3h minus 4. Great. Now once we have that, we can go on to use the FOIL method, FOIL. F stands for first term, O stands for outer term, I is inner term, and L is last term. So a times a is the first term, a times a, that's a squared, a times h, that's the outer term. This is outside, this is outside. A times h is ah, h times a is ah, because we say multiplication is commutative. The order in which you multiply two numbers doesn't matter. And the last term is h times h is h squared plus 3a plus 3h minus 4. So this a squared plus ah plus ah. This ah has a coefficient of 1, and this ah also has a coefficient of 1. So ah plus ah is 2ah plus h squared plus 3a plus 3h minus 4. And this is the value of f of x at x equals to a plus h. Remember, we cannot add these because they're not leg terms. A squared cannot be added to 2ah, 2ah cannot be added to a squared, and so on. So for C, we are told to evaluate this function at x equals to negative 4. So let's quickly move on and do that. F of x is equals to x squared plus 3x minus 4. So we want to find f of minus 4. Now, we replace x with negative 4 here, and on this side, anywhere we see an x, we replace that with negative 4 as well. So this will give us negative 4 all squared plus 3 times negative 4 minus 4. And f of negative 4 will be negative 4 squared. This is very important because it confuses a whole lot of students. Now, negative 4 all squared means you are multiplying negative 4 by itself. Multiplying negative 4 by itself. So that means negative 4 times negative 4. That's what the square means, right? So negative times negative is positive. 4 times 4 is 16. So negative 4 all squared is positive 16. And that is different from negative 4 squared. In this case, the square is not affecting the 4. It's not affecting the negative. In this case, it's affecting the negative. Great. So this is 16. 3 times negative 4 is minus 12, and then minus 4. So f of minus 4 is equals to 16 minus 12, that's 4. And then we have minus 4. So f of negative 4 equals to 4 minus 4, that's 0. So part D says we should find f of a plus h minus f of a all over h. Now, we already found f of a plus h in part B. So what we're going to do is to use that particular result and then minus the result of f of a from that and see what to do. Now, this particular expression, f of a plus h minus f of a over h, will be seen in your pre-calculus course. And this formula is called the difference quotient formula. And we're going to use this to define the derivative in calculus. So let's move on. This was the value of f of a plus h in part B. Now let's move on to find f of a. We know that f of x is x squared plus 3x minus 4. So f of a will be, we just replace x with a, because that's what we're doing here. So this will be a squared plus 3a minus 4. Simple as it is. So this expression is saying that we should subtract the result of f of a from f of a plus h. So let's move on to do that subtraction. So what is f of a plus h? This is it. So we have a squared plus 2ah plus h squared plus 3a plus 3h minus 4. And then minus f of a. F of a is a squared plus 3a minus 4. All divided by h. Great. So all we need to do right now is to multiply this negative by everything in here, and then we simplify. Negative times positive a squared is negative a squared. Negative times positive 3a is negative 3a. And then negative times negative 4 is positive 4. All divided by h. Great. So observe. A squared minus a squared will cancel out because they have opposite sign and they are the same quantity. Now 3a and then negative 3 will also cancel out. Negative 4 and positive 4 will also go out. So what will be left with is 2ah plus h squared plus 3h. That's all will be left here. 2ah plus h squared plus 3h. All divided by h. Now we cannot leave this inside like this because it can still be simplified. So to simplify this, we must divide each term by h. So we have 2ah over h plus h squared over h plus 3h over h. So take each of these and give it its own denominator. So what we observe is that this h and this h are going to cancel out. We're just going to have 2a plus h is going to go into h squared. It's going to go h times plus, and then h and h cancel. We have 3. So if we evaluate this difference quotient formula, we have 2a plus h plus 3.